हेलो, 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 हेलो। ठिक छ त? इभीमै खराब भयो। तपाईँको इभी खराब रहेछ। मैले यसमा क्यामेराबाट यसमा आछ। मैले क्यामेराको यो 1 को क्यामेराको अन गर्छु। हैन अगाडि त आउने नि थियो। हेलो। Check, check. Hey. check. Hey. Hello, check, check. Other basis. Hello, check. Hey.
हेलो हेलो बोलिरहेको हेलो 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 यस्तो गर्नु पर्यो नि हेलो 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 चेक चेक म भन्दा लम्बो आयो नि के यसो चेक चेक ठिक छ आवाज नम्बरिङ गरेछ नम्बरिङ गर्नुभएको छ नम्बरिङ गरेछ भने के नम्बरिङ यो ऊ गरे हो वायरलेस चेक गरे हो
फ्लोरमा भएको 4वटा चाहिँ यो वायर्डमा छ क्या
सिग्नल पहिला चेक गरे हो नि भन्नु खोजेँ
ठिक छ स-
Hello, everyone. Please grab a chair. Anyone standing outside, please come inside the hall. Okay, I think it's time to start. On the clock, 9:43. Only few minutes late. We'll keep the tradition of South Asia alive. So thank you everyone for joining us. My name is Aftab Siddiqui. I work for NPNOG Foundation, but today I'm representing SANOG. Good, now pin drop silence. That's perfect. This is something, this is heartening to see that many people sitting in the room. We still have some capacity. Hopefully more people will show up. I'm not sure how the traffic is, but I'm pleasantly surprised. Last time I came to Kathmandu when Apricot happened. Since then, a lot of positive changes I have seen last night when I was coming here. So it's remarkable how things are working here in Kathmandu. And returning to Kathmandu is always a special for us. This is the birthplace of SANOG, the South Asia Network Operators Group. This is where it all started more than 2 decades ago. When we look back, a small group of people has started a movement which has now become a regional cooperation rather than just a gathering of network operators. Now it has become an umbrella of national NOGs. We have a very vibrant national NOGs in the region, whether it is Nepal Network Operators Group, India Network Operators Group, Bhutan, or Sri Lanka, Bangladesh. Maldives has started, and PKNOG is also trying to wake up a little bit as well. But we have taken a long journey, and today we are as a big regional cooperation organization rather than just a network operators group. I would say thank you to everyone who has participated so far and will continue supporting this initiative in the long run. So let's start the day with the welcome remarks from none other than the chair of the SANOG, Rupesh Shrestha.
Thank you, Aftab. Welcome, everyone. Distinguished guests, friends of SANOG, NPNOG, and NOG community. I am delighted to welcome you all to SANOG 44 with NPNOG 12 event here in Kathmandu, Nepal. As you know, SANOG is a premier community-driven forum for internet infrastructure professionals in South Asia. Established in 2003, SANOG was created to bring together network operators, internet service providers, engineers, researchers, educators, regulators, and technology leaders for a common purpose. That is, to strengthen the technical foundation of the internet through collaboration, education, and shared operational experience. SANOG has helped to start local NOGs, as Aftab also said. So a lot of local NOGs have already started in South Asia and throughout Asia Pacific and worldwide now. Each of the local country NOGs in South Asia now strongly build their community and providing excellent representatives. And then we also have the core SANOG core committee, who constitutes the representatives from each of these country NOGs. So we have representation from BTNOG, BDNOG, LKNOG, NPNOG, INOG, and all the NOGs in South Asia. So SANOG is now the group of the country NOGs. Yesterday, we also completed 4 days of workshop on next-gen routing and network security managed by NPNOG and with help from APNIC and other stakeholders. Total 94 people got training and certified. Today and tomorrow, the program committee has put together a great lineup of very interesting presentations, tutorials, and panel discussions. Thanks to the program committee for that. SANOG being the regional platform, we have started to include internet-related partners to arrange their meeting and programs during the event and have assigned a separate day as a Partners Day on 20th of July. Tuesday, that is Tuesday. As a partners meet where we have APNIC Sub-Regional Forum, Internet Society's community meeting, NREN community meeting, and sponsor session 2. I believe this is just a beginning of SANOG to be a binding catalyst for many internet and network-related organizations to come together in SANOG platform. I'm also very happy to announce that SANOG has received ICIF grant this year from APNIC Foundation to help NOGs for their capacity building and infrastructure support. We are already working on it with all the NOGs under the program. With support from our partner, I'm sure that SANOG and our community will keep on helping to make the internet stable and secure for all. This event, we also have the fellowship program, extensive fellowship program supported by APNIC Foundation and Flex Optics. We have 14 local fellows as well as 8 international fellows represented in participating in this SANOG very successfully. Also, thanks to the fellowship committee for managing all this in a very short period of time. And lastly, thanks to Chairman NTA, Arjun Sir, for honoring us in this as a chief guest of this event. Many people to thank. Probably I can do that towards the end of the event during the closing. So many people have contributed to this event. We have more than 350 registration, and there are still people who are coming on site without registration and then just coming directly and registering on site. We have more than 100 plus foreign participants, which is a good success milestone for us as well. Thank you all the participants for coming over, and thank you very much.
Thank you, Rupesh Dai. Next, we have our very own friend, Samit Jana, from representing NPNOG as the president of NPNOG. Samit.
Thank you, Aftab. Good morning, everyone. Start having a flashback of 4 years back when I was giving welcome remarks. Same sequence, Rupesh Dai, myself. It's just a mirror version, you know. We were on that side, and today we are in this side. A lot of old faces and a lot of new faces as well. Chief guest of this event, Chairman of Nepal Telecom Authority, Arjun sir, distinguished guests, delegates, speakers, and all industry friends. Namaste, and very warm welcome to NPNOG 12 and SANOG 44. At NPNOG, our purpose has always been quite simple. That is to build the technical capacity and build the professional network and community. Every year, we bring together some of the region's best trainers, gurus, and network engineers to deliver hands-on workshop focused on technology and challenges operators day to day. The first SANOG was held in Kathmandu in December 2016 as a small one-day conference followed by a few days of hands-on workshop. 11 editions later today, our mission remains unchanged. But the scale has grown manyfold. Till date, we have trained more than 1,000 network engineers from different industry verticals, and we have trained through NPNOG. Many of now lead critical parts of Nepal internet infrastructure. This remains our greatest achievement of NPNOG, and it would not have been possible without the continued support of APNIC, SANOG, APNOG, NPIX, NREN, ISMAN, our sponsors, and the wider technical community, and also our volunteers and program committee. This year, we are delighted to welcome speakers from more than 10 different countries, presenting over 30 technical sessions. While routing, peering, DNS, network operations, security, and operations remains the heart of our program, we are equally excited to explore emerging areas, including CDNs, data centers, cloud infrastructure, high-performance computing and network, and also AI platform. Today, Nepal stands at a very exciting point in its digital journey. Our fiber infrastructure continues to expand and has reached almost every district of our country. Internet is growing rapidly, as always, and our engineering challenges are also evolving and rapidly day by day, from connectivity now towards cloud, data centers, CDN, AI, etc. And addressing this challenge requires not only better technology, but also stronger collaboration and highly skilled engineers. And that is exactly what this NOG is here for. And today, and over the next couple of days, I encourage each of you to make the most of this opportunity. Attend the sessions, and please make it interactive. Exchange ideas, make connections. The conversation in the hallways, over coffees, and during our networking and social events, and of course with beers, are where many of the best ideas get discussed, and new collaboration will begin. Once again, welcome to Kathmandu, and thank you all for your presence and support.
Thank you, Samit, for the welcome remarks on behalf of NPNOG. The NPNOG community is amazing, and how they've been supporting SANOG here in Nepal is remarkable as well. Thank you for that. Next, we have the Director General of APNIC, Mr. Jia Ronglo, to share his welcome remarks. Thank you.
chief guest from Nepal Telecommunications Authority. Good morning, everybody. My name is Jerong. I come from Singapore, and I've joined APNIC coming to 2 years now. So if I'm a new face, you might not be familiar with me. But coming to 2 years, I realized the past 2 years has flown very quickly. And talking about how time flies, the last time I was in Kathmandu was during Apricot. So that was also a long time ago. So many things have changed. Very happy to be back here again. And coming this morning, met many people whom I've known for many years. So very happy to see old friends again. So really happy to be here. Now, first of all, I'll start with thanking SANOG and the local host, NPNOG, sponsors, speakers, and volunteers for bringing the community together. Very happy that we have large turnout, especially foreign speakers and foreign participants. APNOG and APNIC and SANOG have enjoyed a strong partnership over many years. And we really focus on supporting internet development across the South Asia region. We have very strong participation here today during SANOG and the past few days as well. All of you will know my team members, Shane and Dave. They've been here the past few days, involved in the workshops and during the conference. Chimi and Puwudu, you will see them at the booth outside from our services team. Sunny, most of you would know Sunny. Then my EC members, we have 4 of them. Mas, Archie, Sumon, Perha, they're all here. We are a gold sponsor for SANOG this round, including sponsoring the opening social. And if you add the APNIC family, APNIC Foundation colleagues are also here. So over 10 of us all joining SANOG. It highlights the importance we place for SANOG coming from APNIC and our importance in terms of how we see the South Asia region. Now today, we will also celebrate that this partnership between APNIC and SANOG growing from strength to strength. So today, as part of the opening ceremony, we'll be signing an updated Memorandum of Understanding, which again strengthens APNIC's presence and partnership with SANOG because we will be having a sub-regional forum that will be a feature every year for as long as we can manage it. Now, if you look at the program, on Tuesday, we will have an APNIC track starting from 10 a.m. through lunch. So if you join, you get free lunch, and up to 3 p.m. as well. So between 10 a.m. to 3 p.m. Now, why are we having this sub-regional forum? We do recognize that it's hard to attend APNIC conferences because of the rotation, there's the distance, there's the visas, there's all of these challenges. So we decided, why don't we come to you instead? So this is one of the reasons why partnering SANOG, being the premier regional forum, is a strategic move for us to really be here together with you and to bring our discussions to you instead. So I'd like to invite everyone to come and join us, members, and also wider community on Tuesday. Again, just a shout out, 10 to 3 p.m. Just block that time if you can. Now coming to talking about the region. So APNIC, we have almost 5,000 members in the South Asia region. APNIC has 10,000 members, so half of all our members are from this region. So you are an important region for us, and not only from a number of members perspective, but also from a growth perspective. All the action is happening from this region. So a strong and trustworthy internet infrastructure is key to that growth, to future innovation, of which all of us are excited about. Now, the Regional Internet Registry ecosystem, the RRR ecosystem, and APNIC's governance forms a building block and foundation to the internet's infrastructure. So as members of APNIC, you have a stake in APNIC, which includes our governance. And amongst other topics, I've had members come up to me and ask me, Jerong, especially from this region, they ask me, Jerong, can you give me more IPv4? So, as you know, as APNIC staff, we can't change our allocation policy. Our policy is developed by community, from our stakeholders, from our members. So you have that power, but I don't. So this is but one topic amongst many other topics that's being discussed. Now on policy, again on Tuesday, Dave and Bikram, they will be covering how you can participate, what are the current policy topics that are on the table for APNIC. But at a broader level, there are many other issues that we need your input as our stakeholders, as our members as well. And there's many big topics in the foreseeable future. Just to list some topics, one that we are currently discussing is the topic of how to enhance diversity in APNIC's community leadership. So we recognize, amongst others, the IT industry is male dominant. We recognize that. But looking at the crowd, actually we have many ladies. So how can we build a pipeline again to help us have a more diverse leadership in our community? Not just from a gender diversity perspective, but skills diversity as well. Another topic that will come in the next year, and it's a big topic, is when we implement the RRR governance document. So this is enhancing the RRR governance ecosystem. And we expect the updated RRR governance document to be implemented by March next year. And after that, APNIC, amongst others, will have to implement the obligations that we sign on to for this RRR governance document. And that includes APNIC's framework with the National Internet Registries, or NIRs, because we will have new obligations, which means NIRs will have new obligations. And this is not an APNIC NIR only issue, because NIRs have an impact on APNIC's operations and operational costs, which are funded by members' fees. So again, your participation, your understanding, as we talk about how we're going to implement it, how we're going to update the framework, would be key. And if we look at it from that's other people's problem, not mine, then that's where we are going to have cracks in our system as we go forward. And we are right now at the cusp of strengthening our governance. So that's where all of us need to be involved. Now, tied to all the above is we will be working on our next 5-year strategic plan for the period of 2028 to 2032. So we have to finish an updated 5-year strategic plan by the end of next year. My EC members are here together with me and would like to hear your feedback and your input as to what APNIC should focus on. So again, like I mentioned, we are all busy with our day-to-day work, but your region, the South Asia region, you hold 50% of APNIC stake. And that is why we need to engage with you more, and we are putting in that investment and our time and resources to have these conversations with you every year going forward. So I do hope that we can have more time to talk to you. And if you've not met me before, please don't be shy. Come and say hi. I'd be happy to just chat with you in the corridors or on Tuesday. Now, my last topic for today, in the meantime, IPv6 and RPKI adoption, they remain key focus areas for APNIC. For the South Asia region, we are on a very good trajectory for IPv6 implementation. So South Asia IPv6 capability right now is 66%. And since we're in Nepal, IPv6 capability here is 61%, which is close to the mark. And I'd like to discuss with everyone how can we further push this number up together. Now on RPKI, South Asia ROA stats, excellent. 91% for V4 and 97% for V6. Almost 100% there. And Nepal also has a great number, 99% for V4. I think that deserves a round of applause. And 96% for V6. Now, validation ROV though is abysmal, unfortunately. So 3% for the South Asia region, and almost nothing from Nepal for now. But let's discuss how we as an operator group can move this number up. So from APNIC this quarter, we've also just implemented ESPA, and it will be something we will work with you together as well, again, strengthening our routing security. So I'll close by inviting everyone. Hope to see more of you on Tuesday and in the corridors between now till then. and also inviting everyone who can make it to the APNIC conference in Mumbai in September. So once again, my thanks to the SANOG team, and I look forward to all the discussions at this conference. Thank you very much.
And as Jorong mentioned, we're going to do a quick MOU signing ceremony with the SANOG.
Take a photo with.
Thank you so much. Thank you, Jorong. Thank you, APNIC. And hopefully this collaboration with SANOG will continue for many, many years to come. With that, I would really like to invite the chief guest of the event, Shri Arjun Gimre, the chairman of Nepal Telecom. The telecom industry or the ISP or the network industry of any country can flourish with a good relationship with the regulatory of that country. And it is heartening to see that the chairman of the Nepal Telecom Authority is here among us. So, sir, please, the stage is yours. Thank you.
Good morning, namaste. यस आयोजक संस्थाका पदाधिकारीज्यूहरू, राष्ट्रिय तथा अन्तर्राष्ट्रिय अतिथिगणज्यूहरू, दक्षिण एसियाका विभिन्न मुलुकबाट सहभागी हुनुभएका प्राविधिक विज्ञहरू, दूरसञ्चार तथा इन्टरनेट सेवा प्रदायक संस्थाका प्रतिनिधिहरू, शैक्षिक तथा अनुसन्धान संस्थाका प्रतिनिधिहरू, सञ्चारकर्मीज्यूहरू र यहाँ उपस्थित सम्पूर्ण महानुभावहरूमा मेरो व्यक्तिगत तर्फ र नेपाल दूरसञ्चार प्राधिकरणको तर्फबाट नमस्कार छ। र दक्षिण एसियाको प्रतिष्ठित प्राविधिक मञ्च सानोग र नेपालको NPNOG को सफल आयोजनाका लागि आयोजक संस्था, सहयोगी निकाय तथा यस कार्यक्रमलाई सफल बनाउन योगदान पुर्याउने सम्पूर्ण व्यक्तिहरूलाई हार्दिक बधाई तथा शुभकामना व्यक्त गर्दछु। र महत्त्वपूर्ण कार्यक्रममा प्रमुख अतिथिका रूपमा सहभागी भई आफ्ना विचारहरू राख्ने अवसर प्रदान गर्नुभएकोमा आयोजक प्रति हार्दिक आभार व्यक्त गर्दछु। साथै स्वदेश तथा विदेशबाट नेपाल आउनुभएका सम्पूर्ण सहभागी महानुभावहरूलाई नेपालको तर्फबाट हार्दिक स्वागत गर्दछु। नेपालको आतिथ्य, सांस्कृतिक विविधता, प्राकृतिक सौन्दर्यले यहाँको बसाइलाई सुखद र रमणीय बनाउने विश्वास व्यक्त गर्दछु। र आज विश्व अभूतपूर्व रूपमा डिजिटल रूपान्तरणको चरणमा छ। AI क्लाउड कम्प्युटिङ, बिग डेटा, इन्टरनेट अफ थिङ्स, साइबर सेक्युरिटी तथा आधुनिक नेटवर्क प्रविधिहरूले हाम्रो अर्थतन्त्र, शिक्षा, स्वास्थ्य, सार्वजनिक सेवा र दैनिकीलाई तीव्र रूपमा परिवर्तन गरिरहेका छन्। यी सबै प्रविधिको आधार भनेको सुरक्षित, भरपर्दो, उच्च क्षमतायुक्त र दिगो दूरसञ्चार तथा इन्टरनेट पूर्वाधार नै हो। त्यसैले नेटवर्क इन्जिनियरिङ, प्रणाली प्रशासक, अनुसन्धानकर्ता, नीति निर्माता तथा सेवा प्रदायकहरूको भूमिका आज पहिलेभन्दा अझ महत्त्वपूर्ण बन्न गएको छ। यही सन्दर्भमा SNOG तथा NPNOG जस्ता मञ्चहरू अति महत्त्वपूर्ण छन्। यी केवल प्राविधिक तालिमका कार्यक्रम मात्र होइनन्, ज्ञान आदान प्रदान, अनुभव, नवप्रवर्तन, क्षमता, अभिवृद्धि तथा क्षेत्रीय सहकार्यलाई प्रवर्धन गर्न उत्कृष्ट माध्यम पनि हुन्। यस्ता कार्यक्रमले दक्षिण एसियाका प्राविधिक समुदायलाई एउटै मञ्चमा ल्याई अनुभव आदान प्रदान गर्ने अवसर प्रदान गर्छन्, जसले सम्पूर्ण क्षेत्रको डिजिटल विकासमा सकारात्मक योगदान पुर्याउँदछ। नेपालको पछिल्लो वर्षहरूमा दूरसञ्चार तथा सूचना प्रविधिको क्षेत्रमा उल्लेखनीय प्रगति हासिल गरेको छ। इन्टरनेट सेवाको पहुँच विस्तार भएको छ। फाइबर अप्टिकल नेटवर्क तीव्र गतिमा विस्तार भइरहेको छ। मोबाइल ब्रोडब्यान्ड सेवाको प्रयोग बढ्दो क्रममा छ। डिजिटल सेवाप्रति नागरिकको विश्वास निरन्तर वृद्धि भइरहेको छ। र यद्यपि अवसरहरूसँगै चुनौतीहरू पनि उत्तिकै छन्। नेटवर्क ट्राफिकको तीव्र वृद्धि, साइबर सुरक्षाका जटिल जोखिम, डेटा सुरक्षाको आवश्यकता तथा गुणस्तरीय र भरपर्दो सेवाप्रतिको बढ्दो अपेक्षाले हामीलाई अझ सक्षम, दूरदर्शी र उत्तरदायी बन्न प्रेरित गरिरहेको छ। नेपाल दूरसञ्चार प्राधिकरण नियामक निकायका रूपमा गुणस्तरीय दूरसञ्चार सेवा विस्तार, उपभोक्ता हितको संरक्षण, स्वस्थ प्रतिस्पर्धाको प्रवर्धन, प्रविधि मैत्री नियमन तथा सुरक्षित डिजिटल वातावरण निर्माणका लागि निरन्तर रूपमा कार्यरत छ र यसलाई अझै थप प्रभावकारी बनाउँदै लग्नेछ। र हाम्रा भविष्यका प्रविधिहरू 5G, IPv6, क्लाउड इन्फ्रास्ट्रक्चर, इन्टरनेट एक्सचेन्ज, डेटा सेन्टर, AI आधारित नेटवर्कहरू व्यवस्थापन तथा साइबर सुरक्षाको सुदृढीकरणलाई ध्यानमा राखेर नीतिगत तथा प्राविधिक तयारीलाई निरन्तर अगाडि बढाइरहेका छौँ। कुनै पनि राष्ट्रको डिजिटल भविष्य केवल पूर्वाधार निर्माणबाट मात्र सुनिश्चित हुँदैन। त्यसका लागि दक्ष मानव स्रोत, अनुसन्धान, अन्तर्राष्ट्रिय सहकार्य, नवप्रवर्तन र निरन्तर सिकाइ आवश्यक हुन्छ। र यस्ता संस्थाहरूले यही उद्देश्यलाई सफलतापूर्वक अघि बढाइरहेका छन्। विशेष गरी यङ इन्जिनियर, विद्यार्थी तथा नयाँ पुस्ताका प्राविधिकहरूका लागि यो कार्यक्रम विश्वसनीय, ज्ञान, व्यावहारिक अनुभव तथा अन्तर्राष्ट्रिय सञ्जाल निर्माण गर्न अनुपम अवसर हो। यहाँ प्राप्त ज्ञान र अनुभवले नेपालको डिजिटल विकास यात्रामा दीर्घकालीन योगदान पुर्याउनेमा म विश्वस्त छु। आज एआईले नेटवर्क सञ्चालन, ट्राफिक विश्लेषण, सेवा गुणस्तर सुधार, साइबर सुरक्षाको सुदृढीकरण तथा स्वचालित व्यवस्थापनमा नयाँ सम्भावनाहरू सृजना गरिरहेका छन्। तर प्रविधिको विकाससँगै सुरक्षित, जिम्मेवार, पारदर्शी र नैतिक प्रयोगमा पनि समान ध्यान दिनुपर्ने आजको आवश्यकता छ। नेपाल दूरसञ्चार प्राधिकरण अन्तर्राष्ट्रिय समुदाय, सरकार, निजी क्षेत्र, प्राविधिक समुदाय, शैक्षिक संस्था तथा विकास साझेदारहरूसँग सहकार्य गर्दै सुरक्षित, समावेशी, दिगो तथा भविष्यमुखी डिजिटल इकोसिस्टम निर्माण गर्न प्रतिबद्ध छ। र हामी विश्वस्त छौँ कि ज्ञान, सहकार्य र नवप्रवर्तन मार्फत मात्र डिजिटल भविष्यलाई अझ सुरक्षित, भरपर्दो र समावेशी बनाउन सकिन्छ। अन्त्यमा यस महत्त्वपूर्ण कार्यक्रमको सफल आयोजनाका लागि आयोजक संस्था, सहयोगी निकाय, प्रायोजक, प्रशिक्षक, स्वयंसेवक तथा स्वदेशी विदेशबाट सहभागी हुनुभएका सम्पूर्ण महानुभावहरूप्रति हार्दिक धन्यवाद व्यक्त गर्दछु। र म विश्वास व्यक्त गर्दछु कि यस्ता संस्थाहरूबाट प्राप्त हुने ज्ञान, अनुभव, अनुसन्धान र सहकार्य नेपालको मात्र होइन सम्पूर्ण दक्षिण एसियाको दूरसञ्चार तथा इन्टरनेट पूर्वाधारलाई अझ सुरक्षित, भरपर्दो, समावेशी र भविष्य उन्मुख बनाउन महत्त्वपूर्ण योगदान पुर्याउनेछ र यही विश्वासका साथ यस कार्यक्रमको पूर्ण सफलताको हार्दिक शुभकामना व्यक्त गर्दछु। धन्यवाद।
Thank you, Mr. Shri Arjun Khimre. As a tradition of Nepal, we would like to do the lightning of Panas, and I would like to call upon our chief guest, Mr. Arjun Khimre. Sir, we would like to call you for the lightning of Panas as well. Right. Thank you so much, Mr. Arjun, for your kind words and the lightning of the Panas as well. I learned something new as well. I was asking my friend that what does it significant. So it has a lot of positive energy and positive value, and I hope this will bring more positivity during the next 3 days of the event. So with that, we'll go towards the keynote speeches. We have two very interesting keynote speech. First one, I would like to call upon Binay Mohan Saud. He's the CEO of CBC Limited.
Namaste. Sorry for the small font hiccup. Yeah. So today, 2026, myself, Binay Mohan Saud, CEO of Subisu Limited, will be presenting you presentation on Internet to Intelligence, reinventing ISP for the AI era. Welcome. Welcome especially to our chief guest, to the chairman of NTA, as well as all the international delegates who have come all the way for this conference, as well as who are present in the room for the conference. It's 12th NPNOG conference, 44th SANOG conference, and I'm proud to mention that we hosted the first SANOG conference in 2003 in Kathmandu, Nepal. Today, 2026, NPNOG is 10 years old and SANOG 23 years old. A very great congratulations to NPNOG on the 10th birthday and SANOG on the 23rd birthday. I guess everybody has their internet journey. And mine too started in mid-90s. I still remember the day when I went to see how an email is sent. I reached the cafe, and when the operator said that the email is sent with a buzzing sound, many things came to my mind, and I thought that it will be a different world in the coming days or in the coming decades. Then opened up Hotmail account, Yahoo Mail, which was a prestige among your peers at that time. And I'm sure you also remember the ICQ, a free chat. That was the dial-up period. After coming back to Nepal from my engineering days, one of my friends was studying in India, who is my partner now, sent me a newspaper clipping indicating that triple play, dual play is being popular around the world, and in India, they are doing a test. So we thought, why not in Nepal? We applied for a license, and only on the third time, we got the license approved from NTA, and we started our journey in 2004 with our DOCSIS technology. Let's look back to the era that sparked the digital revolution, 1990s, era of internet, which introduced to the world of connectivity and network that fueled modern businesses like communication, data sharing, search engine, software, online businesses, online payments, research, streaming, remote work, and many more. And 2000, it was an era of ISP, NSP in Nepal. That was when it really got traction, and a lot of development happened in Nepal with the ISP sector. I would like to take you back. In 1994, dial-up service was started by a local company in Nepal, Mercantile. And as I informed earlier, in 2004, the broadband license was given to Subisu, and we started with a DOCSIS technology at that time. Along with DOCSIS, we also started with our Metro Ethernet solution, which connected different offices. For your information, at that time, the offices having no alternate, they had already started connecting their offices with the VSAT technology. In 2008, MPLS started, once we started going nationwide. And the government also approved the interconnection. The first interconnection that happened was with Airtel, with the private entities. In 2014, FTTH started. With the start of FTTH, the bandwidth requirement increased, and Several of the ISPs started their DWDM solution in 2018. Now we are here, 2025-26. We are with Wi-Fi 6 and XGS-PON. Yes, you saw it right, 107. We have 107 licensed ISPs, but out of that, only around 15 are very active. 25 licensed NSPs, the network service providers. Now we have around only 7, 8 very active NSPs at the moment, and 2 telecom operator. From the NTS stats, we can see that the mobile connection is around 32.5 million. The internet penetration is around 56%, with internet users around 16.6 million, and the broadband users around 3.5 million. The fixed broadband, I mean to say. On the traffic part, out of the total traffic, IPT traffic holds around 15%, and the CDN around 85%. That comes around IPT around 3 terabits per second, 3 terabits, and CDN around 23 terabits. Something that sparked digital revolution again. Era of AI, artificial intelligence, which introduced us to the world of LLM and RAG, large language model and retrieval augmented generation. 1990 internet era, which introduced to the world of connectivity and network. 2020's AI era, which introduced us to the world of LLM and RAG. The internet era connected us to the devices, and the AI era is now connecting the intelligence. For both of these, internet is the driver. So this is just my interpretation. What was internet in the 1990s, AI is today. Internet with connectivity and network, AI with LLM and RAG. Connectivity, LLM, networks, RAG. Same revolution, different era, same pattern. Today, I'm not here to discuss about AI. It's a different world. But what I believe is AI is today the foundation built by internet, connectivity, and network. So where should the industry go? The house that was built on the foundation of internet, connectivity, network has become powerful and intelligent in the name of AI. So what should we do? Do we need to compete? My answer is big no. The job is still not done. AI still needs us. But why? House is built, but what about the roof? Confused? Yes, you heard it correctly. The digital infrastructure. This is where we should focus, creating digital infrastructure for the next generation technology, that is AI. For the last 30 years, we built networks for humans. For the next 30 years, we will build digital infrastructure for AI. What is digital infrastructure? The new stack of digital infrastructure are data centers, cloud hub, cybersecurity, high-speed carrier, SD-WAN, IoT, edge computing, AI infrastructure, CDN, and digital identity, and many more. I just want to give a glance about internet business in Nepal. Presently, we are providing retail and enterprise customers with internet and intranet. The customer expectation keeps rising, and the bandwidth demand doubles every few years. Challenges: the ARPU is flat, declining margins, but the cost of operation is increasing, and as you know, that gives a high ROI, the return on investment. To be ready for the AI era, we will need new investments in technologies like Wi-Fi 6, native IPv6 adoption, SD-WAN, AI-driven networking, automation, security, data centers. These are all capital-intensive products. But this can be achieved only through collaboration over competition. That can only be done when we start having infra sharing, security, data center, interconnects, native IPv6 adoption, training, research, open peering. Is this enough? Still no. So what's next? We should be reinventing ISP for the AI era. But how? Internet connectivity and network laid the foundation of AI. Now, ISP should incorporate intelligence to become more smarter and relevant. So for that, we will need to make our support intelligent. How? We can make AI assistant call centers, multilingual support, auto follow-up, AI diagnostics, automatic trouble ticket, automatic device health check, customer satisfaction behavioral analysis, churn prediction. Similarly, NOC can also be intelligent. AI fault prediction, auto root cause analysis, automatic ticket classification, capacity prediction, demand forecasting, predictive maintenance, traffic anomaly detection, fiber cut protection. Engineering also can be intelligent. Capacity planning, traffic engineering, intelligent routing optimization, configuration validation, network documentation, automatic change review, configuration generation, predictive risk analysis. Business also can be intelligent. AI lead scoring, opportunity prediction, sales forecasting, demand forecasting, AI sales assistant, customer lifetime value prediction, cross-sell, upsell recommendation, usage pattern analysis. We can also make customer experience intelligent. Smart package recommendation, plan comparison, self and auto support, coverage availability check, smart home monitoring, knowledge assistant, usage analytics, AI troubleshooting. As you can see, there's unparalleled opportunities for all ISPs, NSPs ahead. The wave has just begun. Capacity requirement will be 100G, 400G, 800G, and maybe 1.6T also. Ultra-low latency will be the requirement at that time, so we will really need to strengthen your backbone. Edge computing, inference must move closer. We need to have the AI computing cannot have outside Asia. So I think regional and local data centers will also benefit in that case. Hyperscalers like AWS, Azure, Google, Alibaba, Meta, Oracle requires local presence, dedicated connectivity, cloud exchange, peering. As you can see, AI needs more network and resource than human, which will create unprecedented opportunities. Thousands of GPUs, hundreds of GBps, petabytes of data. What's in here for Nepal? Endless opportunities, but we need to leapfrog with our strength. We have young tech population, growing digital economy, high mobile adaptation, rapid fiber deployment, clean energy hydropower, strategic location between India and China, growing software industry, digital payment ecosystem. Nepal also has the opportunity to become a neutral hub. Regional cloud hub, regional data hub, AI inference hub, disaster recovery hub, digital service hub, cross-border transit hub, managed service hub, content delivery hub. So what should be the roadmap for Nepal to achieve this? We need to build an AI-ready infrastructure, high-capacity networks, cross-border connectivity, more interconnects, local AI inference, research collaboration, university partnerships, open peering. For this, what we are asking for from government and regulators, I think we have the NTA chairman here. The policy needs to be very transparent. As you can see, it is a capital-intensive project where investors or business owners want to be really clear with their ROI. So the government policy should be very transparent so that they are more attracted to invest in Nepal. Similarly, to address the AI era requirement, high bandwidth, low latency, we will need more spectrum, even for Wi-Fi. For Wi-Fi 6E, 7 and above, we will need spectrum. So NTA will need to really look into the requirement of spectrum. And definitely, the government needs to incentivize new entrepreneurs who are interested to come into this field. Vendors and international partners, they have played a major role in the last 3 decades. They have really handheld us in giving us new technology and getting our people trained. I also would like to take this opportunity to thank vendors like Airtel, Tata, Cisco, Juniper, Huawei, Nokia, JT, for all the support that you have given over the last few years. And as you can see, there is more prospect and hope you will keep on supporting us in the coming days also. To the technical community, I think we will need more collaboration trainings to be ready for the AI era so that we can build our expertise and to deliver as per the requirement. I also want to thank, I have a list here. I want to make sure that I take most of the names. So, yeah, so I would like to, in the community part, I would like to thank SANOG and NPNOG, ISPAN, NREN, FCAN, Apricot, APNIC, CAN, APNIC Foundation, ICANN, PCH, BTNOG, BDNOG, INOG, ISOC, and NIXI. And I forgot to take the CDN providers, thank the CDN providers like Google, Meta, ByteDance, and Akamai also. And I think in the coming years, we'll need more CDNs and we get help from the CDN providers also. So the key takeaway on the internet, 30 years ago, people connected to the internet. Today, internet connects people. Tomorrow, internet connects AI, machines, and robots. ISP, NSP business. Earlier, we sold bandwidth. Now, we sell digital experience. In the future, we sell digital intelligence. The traffic has changed. Previously, Google and Yahoo. Now, TikTok, Meta, YouTube, Netflix, and gaming. Soon, AI inference, video AI, voice AI, AI to AI communication, machine-generated traffic, agentic workflows. Yes, it's not just about now bandwidth, latency, jitter, or packet loss. It's more now about CPU, GPU proximity, inference, latency, cloud access, API performance. So I come to the last presentation sheet. So in the 1990s, we connected people with email and internet. 2000 connected information with internet. 2010s, we connected everything with internet and cloud. 2020, we connected intelligence with internet and AI. And in 2030s, we connect automation with internet and automation. In the last 30 years, from dial-up to XGS-PON, I think internet has been an integral part and will remain in the next another 30 years or more. Thank you.
Thank you, Binayji, for a good session on reminding us that how we came here and what do we have to do in the future. With that in mind, I have the second keynote speaker, someone I think we all know very well. If we don't know them, so let me give a little bit of introduction, though that person does not require an introduction. Someone, you heard about APNIC, someone who started APNIC in the early days of APNIC, when it was first registered as an entity. Someone who started Apricot, which is now an institution in the region. Someone who started some of the very, very good initiatives in ICANN. So someone who has the habit of starting something new and move on, and then start something new and then move on. I'm not sure what that person is doing right now. But let's see and figure out and find out what he's doing. Let me invite my mentor, a friend, someone who has been gifted with a lot of information, knowledge, and wisdom, and has kindly accepted the invitation to come to SANOG, Mr. David Conrad.
Thank you, Aftab, for a lovely introduction. I don't know who you were talking about, but I'll stand for that person if I can. So thank you, everyone, for inviting me here and for listening to this talk. 30 years ago, when myself and a friend, Barry Green, created Apricot, the first attendance for Apricot was about 80 people. And in the 30 years since then, it has grown significantly. And one of our dreams, Barry and I, was that it would spawn off NPNOGs throughout the region for folks to basically transfer information, knowledge, and understanding about how networks were to operate. And just what I've seen at SANOG and NPNOG suggests that we might have been successful in our dreams, but through the hard work of everyone who attends these meetings, you all deserve a round of applause. So thank you for the efforts that you have done. So as Aftab pointed out, I tend to start things and then run away before anyone can blame me. In this particular case, right now, I'm an advisor to a small nonprofit called CyberGreen. It's run by someone you may know. Her name is Yurie Ito. She was involved with JP Cert and AP Cert. She's well known within the security fields. And one of the things that we've been doing is trying to understand how we can improve the security of the internet. You know, what models can we apply to security of the internet? And, you know, do basic research on improving the security that underlies the internet technologies that we use. So, to start into that discussion, we decided to sort of look at something that's really easy to identify, the DNS. And there is a well-known haiku out there that I'm sure some of you may have heard. It's not DNS. No way it's the DNS. It was the DNS. And if you're a network operator, you have probably encountered this haiku. Either you have experienced it yourself as systems are collapsing around your feet, or you've seen it impact your customers when they're unable to reach the sites or the services that they're interested in. So we decided to sort of dive into this and find out exactly, you know, what the real situation is. And I have to couch this in terms of what I could get funding for sitting in the US. So there was a pot of money that was associated with looking at rural health services within the US. So we decided to look at the DNS within the US rural health system. And when you're looking at the haiku, you know, it basically says, one interpretation is that the DNS is fragile, so of course it fails. The DNS is basically a black box that breaks easily. So it will betray us at every opportunity, and you have to be very careful about it. But when we started looking into the failure modes and why the DNS was failing, the DNS protocol itself, while it's incredibly complicated, I'm sure many of you have heard of the DNS camel, that is a description that a guy named Bert Hubert in Amsterdam had said for the way the protocol has evolved over time, sort of designed by committee as opposed to anything that anyone rational would put together. What generally fails is operational hygiene. The human-managed infrastructure that surrounds the DNS, that serves the zones, the unbelievable complexity that we have inflicted upon ourselves in order to meet customer demands, software that lets people shoot themselves in every part of their body, and whether anyone is actually watching the indicators that show the DNS is actually on its way to failing before it actually fails. So when you're trying to investigate these things, you need some sort of lens to look through the myriad of data that you're collecting. And what we've been doing at the CyberGreen Institute is taking the analogy of public health and applying it to the cyber world. So instead of dealing with individual events as they occur, you try to look at populations and identify trends within those populations, and then attempt to come up with remedies that address those trends so that instead of solving the problem for one or two, you're actually solving it for the entire population. So back in 2011, some researchers, Mulligan and Schneider, presented this concept of cyber public health. And there's a working group that looks at applying public health models. The analogy is not perfect. Public health typically doesn't involve human-directed antagonists. So the malware creators and the bad guys who are actually leveraging known vulnerabilities. But it turns out that in the public health field, evolution does sort of the same thing. It will find any weakness and learn to exploit it over time. And generally the concept is you measure things. When you find something, you notify, you learn as much as you can, and then you apply those into the next set of measurements. So, as I mentioned, at CyberGreen, we have this U.S. Rural Health Cyber Initiative. And what we're doing is we're looking at rural healthcare. Why? Because we could get money for it. And we're using the DNS. Why did we choose the DNS? Well, because it's easy, and it doesn't generally cause people to think you're attacking them. So it also happens to be a critical infrastructure that nearly everyone depends on, and there are a whole bunch of indicators within the DNS that are actually interesting to track. So we focused on one specific thing, which is delegation health, looking at how the DNS parent-child relationships are established and everything that you can possibly think deriving out of that relationship. We do a scan across all of the rural health facilities that we could identify, set up a score, and then track that over time. So we have a time series of events that we've noticed, and we just track those on every scan. We do a scan daily. This is all very much a work in progress, so I don't actually have a whole lot of pretty graphs to show you, but that'll be, maybe next year. So once we identify things, we notify when we can identify who to notify. Because CyberGreen is not very well known, we actually corralled in the use of an organization called Health ISAC. Health ISAC has about 10,000 members that are health facilities, and they provide cybersecurity related advisory services and help to hospital facilities across the world, not just the US. So we contacted them, and they serve as our trusted notifier to contact their members and say, hey, you have a problem, and here are the steps that you use to fix it. And we give them a little survey to hand to the people that they notify, and they respond back. And we learn based on those experiences and might pipe that back into the measurements. This does actually work. In our initial prototypes, we submitted notifications to a bunch of places, and we noticed significant improvement in a few of them when they were able to identify or take the steps that we told them to actually fix things. They went and fixed things, and their health scores improved drastically. Sort of a dense slide, won't go into this too much, but we have a challenge in that for the rural health facilities, they don't, the federal registers that we use, we don't actually have URLs for these health facilities. We actually had to go and find them, which had to play all sorts of weird games using Google Maps and then deriving URLs from those maps and then making sure those URLs actually map to the health facility. It gives a lot of money to Google, but we eventually were able to establish 1.8 million health facilities just within the US. Of those, about 40,000 are considered rural. Of those, about 8,000 or so are considered critical health care facilities. If something happened to them, if they went down from an internet perspective, it's possible people could die. So those are the targets that we used for this initial pilot project. We have something that will collect the URLs, derive the zone apexes of those URLs, and then create a score. And then the delegation checker runs through a whole series of tests and evaluates the site to determine whether it's good or bad in terms of its general hygiene. So first, the good news. I know this will shock you, but the DNS actually does generally work. The median health score for these 8,000 plus clinics throughout the US was about 94, mean 86, and about 75% were actually excellent. They scored between 90 and 100 using numbers that I basically pulled out of various bodily orifices. They are almost random, except, hopefully they actually correspond to something useful. So at a face value, the DNS actually looks fine. The queries resolve eventually. Sometimes there are delays for various reasons. pages generally load, and on a uptime dashboard, nothing's going to show up. Unless you're actually looking into the details, everything looks sort of fine. The problem is that this actually hides some real problems. So yes, about 3/4 are excellent, but you have a long tail of some really amazingly bad stuff out there. In general, 739 domains score poor or critical. 34 of the domains actually had a 0 score, which meant nothing was actually working the way it should. Sometimes they would still resolve, but only through implementation decisions of particular resolver operators. So they did not have universal resolvability. The endemic conditions, so a lot of them are really minor, little things. Like the SOA minimum being too high. Does that matter? Almost all the time it doesn't. EDNS buffers being too small. Again, most of the time it doesn't matter. Occasionally you start seeing fragmentation, and particularly if you're using DNSSEC, that can cause packet loss, which delays resolution. Where you start seeing significant prevalence is in areas that operationally tend to make sense from a single provider perspective. Things like having all your name servers in a single AS. Simply, you have a provider, so you put 2 name servers. You might actually put them in geographically distributed points, but they're all under a single AS. So if that AS has an issue, the DNS will fail for those sites. Similarly, and you can get into arguments about this, not having DNSSEC. Some people will say that's a positive, other people will say it's a negative. I personally actually hate DNSSEC. The only thing I hate more than DNSSEC is not having DNSSEC. Sort of like RPKI. I really don't like it. It drives me crazy, but it's better than the alternative not having it. So, as I said, these numbers that I came up with for scoring are kind of made up. I made them up. So one of them is treating DNSSEC. If you don't have DNSSEC, I call it a medium severity. It's not critical, but it's not actually very good. But only 6% of the sites that we looked at had DNSSEC. We did do this test on other populations. I'll talk a bit later about .bank, where the DNSSEC implementation is much, much higher, and that suggests a possible solution. But there's also, at the bottom here, you see 96% of sites are in a single country. Not surprising given this is US healthcare facilities, but it actually follows through. If you actually look at DNS in other populations, they tend to be geopolitically located into a single venue, which means that if there is, say some crazy head of state who decides they don't like a certain country, that can have an impact on your entire DNS resolution structure. And I'm not going to go with any names, of course. So the acute conditions in the healthcare world, there's chronic and there's acute. Acute is things that basically call you to fall over dead. So the acute conditions, again, against these 8,000 rural health facilities, 10 of them actually had zone transfer wide open. So you could get their entire zone file just by doing a single query. A number of sites don't have NSs published in their child. So they're parent-centric, which in some places makes sense. I've understand that some resolver developers now, ISC in particular, is moving toward a parent-centric model where it does not depend on the name servers that are specified within the child. And that's fine, but it's a different model of operation than we've relied on historically, where the child is in control of their destiny. So that's something that network operators probably need to be aware of when moving forward, whether they're okay with having parent-centric or child-centric. Similarly, there are a surprising number of zones that don't actually have an SOA. And that can have an impact on how resolution actually occurs once, for example, an NX domain depends on values, how long the NX domain is kept in a cache. It depends on values in the SOA. If there's no SOA, then the resolver gets to decide, and sometimes that can lead to some surprises. There are 413 parent-child mismatches. That's more colloquially known as lame name servers. And those can actually, lame name servers can actually lead to domain takeovers and having people redirect the traffic for a site to an attack-controlled infrastructure. So all of these are significant issues and suggest that fundamentally, while the DNS does generally resolve, there are certain cases that are worrisome and that lead to the DNS always being the problem. In other words, it wasn't really the DNS, it was us. It was the configurations that we use in the DNS. And all of this was a human choice. So really the question becomes, isn't why is the DNS flaky? It's, why does an entire sector share basically the same untreated symptoms? And what can we do to fix that at scale? Like I said, you can go and touch individuals, and so far in our pilots, we're getting about a 5 to 10% intervention return rate. But that is in the noise when you're talking about 1.8 million. So we need to do these things at scale. So looking at treating the population. So interventions, in the real public health world, you have these intervention mechanisms. This is a set of proposals on how to apply that model into network operations. So as you're probably aware from the fun days of COVID, there's screening. You can screen people to tell if they have a disease. You can have vendor or provider enforced enforcement. You can have notifiable disease reporting, which is extremely common in the public health world. And you can try to rely on herd immunity. So, intervention 1, screening as a public utility. What this translates into in the DNS world is you have hygiene scanning, doing the same thing that I've been doing with the code that I wrote, Del Checker. And just as an aside, that will be made open source. I'll publish it when it is less embarrassing. I stopped writing code about 20 years ago for very good reasons. I suck at coding. So at some point, once it gets to a point where I'm not too embarrassed to be seen, I'll actually put the repo out for public. There are a myriad of other zone scanning tools. Zone Master is a really good one. I needed to do something different, scanning whole populations, so I ended up writing my own. But having a population scanning for DNS issues and then a notification mechanism would allow us to notify particular organizations and patients of issues. There is precedent for this. In the US, there's the Cybersecurity Infrastructure and Security Agency, CISA, that has an opt-in program where you can put in a domain and it'll do various tests, or either that or an IP block, I don't remember exactly. UK has the NCSE doing something similar, and it's opt-out. They do it by default, and if you don't want to be scanned, you tell them, and they will do it, or they'll remove it. The downside of this is you're scanning the infrastructure you don't own, and it may be unsolicited, it might be seen as an attack. How do you pay for it? Like I said, right now, I'm doing this on Google infrastructure, and it's kind of pricey. The underlying infrastructure itself, you could put on a very simple machine, but if you're going to do it at scale, you actually need some significant bandwidth and significant horsepower. How do you notify? This turns out to be the real challenge. We're able to identify thousands of potential organizations, finding who to actually contact and having them respond to that contact is very challenging. Who holds the results? Sometimes this can be seen as sensitive information. As I said, this can be seen as an attack. I did have a scenario where an organization that was helping us actually sent someone to a clinic to actually say, look, your DNS is really broken, you're running a very big risk. And it ended up the person who went to the facility got the police called on them because somebody was at the front desk saying bad things are about to happen. So now obviously the receptionist called the police. Intervention 2, so quarantine and gatekeeping. Everyone is probably familiar with this concept. We all went through it during COVID. So the basic idea here is to disallow certain configurations that fail the basic tests. So you ensure parent-child consistency, 2 reachable name servers, no open recursion, and this is protected at the initiation for an entire population that is using that particular vendor. There is a precedent on this. The top-level domain .bank has very stringent requirements for its registrars, and as a result, the registrars have actually very good scores for their DNS for .bank registrants. So conceptually, this works. It does fix a problem at one choke point, and a registry policy or a provider approach would protect millions of downstream customers. The problem is it is a cost to the providers. It means that you might generate a customer support call. So, blowing away the profit that customer might bring for you. It can, if you actually impose this post facto, it can knock people who were actually getting service off the net. So are you able to do this? Well, you probably have to work very carefully with your customers, at least the existing customers. Intervention 3, notable disease reporting. This is something that I actually championed when I was at ICANN. I really thought it would be a good idea if registrars who experienced vulnerabilities or were attacked would relay the vulnerability and the attack to a central clearinghouse at, say, ICANN, and that information could be shared. It is challenging to get that through various organizations because it does imply that they are releasing potentially sensitive and damaging information. Airlines have to do it for any sort of air traffic incident. So if you're considered certain types of critical infrastructure, you don't have a choice by government mandate. Whether or not the DNS is actually considered sufficient for that level of reporting, so far it hasn't been. But as increasingly countries turn to the internet and DNS for their GDP, it may come to be a point where this sort of mandatory reporting is necessary. The challenge is that it does impose a certain level of regulatory overhead to doing anything that currently is not charged. So this sort of regulatory thing is generally seen as bad within the internet world. Whether or not this actually occurs remains to be seen. And finally, intervention 4, the herd immunity. This is an attempt to reduce the chances that the disease will spread by making it harder for the disease to find a foothold, i.e. improving the hygiene generally across the system. This is something that is actually happening. The 3/4 of the facilities, rural facilities that have good scores, they tend to be on a very small number of usual suspects, folks like Cloudflare or registrars like GoDaddy. Those organizations generally do things correctly, so as a result, they are less vulnerable to various attacks that leverage these vulnerabilities. That is a problem if, for example, not to name names, but if a CDN that starts with C happens to go down, that can take out huge swaths of the internet infrastructure, and that in and of itself is a problem. So you're actually moving from one disease to another. The common thread across all of this is that these clinics are under-resourced. This is a common thread throughout the entire industry. There are things that I'm sure we would all like to do to minimize the negative hygiene aspects, but we don't really have the resources to do it. So what can we do? So what we're trying to suggest at CyberGreen is that we focus not at the individual level, not at the provider level, but focus at the layer above that. Try to hit the parts of the infrastructure that will hopefully address millions of customers as opposed to individual customers. The short answer is that it actually does not have to be the DNS. All it has to do is make sure that whatever hygiene you have is supportable across a population. You can track across your own populations anytime something shows up that is consistent across your customers, may be an indicator that there's something that you can do to minimize that impact across those customers. And with that, I thank you again for having the privilege of speaking to you here today.
Thank you, David. So certainly it is DNS. So as a network engineer, it's music to my ears whenever I hear about this. But I can see one of my friend, Dev Das, sitting in the audience who says, no, it's not DNS. But anyway, we'll talk about it in the next, later today and next day as well. But before that, let me call upon Ramesh Dai for giving a token of appreciation to our speakers. And let me call David and Binay Mohan South and also Jiarong Lo and Samit. Please.
Where is Aftab? Okay, I thought we lost him.
All right. So now this is the last session, okay? And this is something very important. So I need a little bit of attention from all of you. And this is This is important for me, important for for our community, and important for the next generation as well. So, remember when earlier I said that NPNOG started in Kathmandu, and Kathmandu has a great significance of starting initiatives like, of course, NPNOG, and then multiple other things. The fellowship program you have seen in many places, it also started here as well. The program committee, the submission system, it also started here as well. So we couldn't figure out, we believe that this is the place where all the initiatives in the South Asia should start for it to progress. Today we are launching Internet Enablers National Awards. So if you attended Apricot earlier this year, you must have seen what is Internet Enablers. But most of you are new to this. So let me explain what is Internet Enablers. So I need to read few things so that I don't skip anything out of the information I want to share with all of you. So it all started, so let me say, fine, when we were hearing from Vineda that how it all started in Nepal, that how Subisu started back in 1990s. This is the story of one ISP, but we have heard the stories of many ISPs. But we haven't heard the stories of people behind those ISPs, behind those initiatives. Behind every reliable internet connection is a story that's really being told. I have been in this ecosystem, in this industry for almost 18 years. Many of you have been there for more than that. But a lot of you are new, youngsters as we call it, or the Gen Z. If something started back in 1990s, I think a lot of people were not even born. This is a realization which reminds me that I'm old. And yes, someone is mentioning my hairs. So it is also a sign for that. But those individuals who built the internet in our region, specifically in our region back in 1990s, it was developing, it was struggling with infrastructure, with technology, with everything, with people, with education. We were growing up. I still remember in early 90s, I was still in school. I had no idea about internet up till year 9. That is 1995, 1996. And things were happening in the western side of the world quite rapidly. But people in our community were not sleeping. They were working really hard. Those people, when I started high school, we got the internet. It's because of those people. So that's why, and then one day we realized, then we need to list down the names of those people who actually built that internet. In India, in Pakistan, in Bangladesh, in Nepal, in Bhutan, in Maldives, in Sri Lanka. Who are those people? I was born and raised in Pakistan. I knew some of them. So this discussion started in 2023 Apricot. And during one of the infamous whiskey boffs, which happens in a very secretive location, where we talk about things happening in South Asia. And some of us who are in this room started that discussion. It was the first in-person meeting after COVID. And that started as a normal conversation, became a conviction, because some of us who's been part of this ecosystem could not figure out who started internet in some of the regional economies. And we struggled. So that discussion became a conviction. We need to do something, and we need to do it quickly. Because those people who started early in 1990s will be coming to a retirement age or have moved on and doing something else. We need to preserve their names for our younger generation. so that when they started using internet as a necessity, as a part of their life, should be able to recall that that person I know started internet in India, in Pakistan, in Bangladesh, and all the South Asian economies. So that they can remember, they can put a name to a pioneer, a face to a pioneer. We all know about the father of internet, Dr. Windsurf. Who is the father of internet of Nepal? Can anyone tell his name? We have, see, everyone is struggling. And you will figure out, you will come up with multiple names. But that's not a problem with one economy or one country. We have maybe a lot of pioneers who built the internet. It's not just one person. It was a collective effort. Because, as I said, it was a growing region. It still is a developing region. But we have came a very long way. From kbps to terabits per second. This is the most developing region in the world. And of course, most populous as well. So the next big thing will happen in this region for sure. So we started this initiative called Internet Enablers. And the first award for the region was given earlier in Apricot. But it all was made possible with the support of very few people. One of them is Rupesh Dai, who supported this initiative. And I have to recognize one organization. Even though I now work for APNIC Foundation, when I started this discussion and we started this initiative, I was not associated with APNIC Foundation. But Raj, who is the CEO of APNIC Foundation, heard about this idea and he said, tell me how to support you. So it was only made possible because of these two people who said, we will support you, let's go and do it. So the regional, the Asia Pacific Award was given to none other than one of the, I wouldn't call it a father of the internet of Nepal, he's not that old, the pioneer of the internet of Nepal, Gaurav Dai. So we gave him the award of Asia Pacific. So he not only did amazing work for Nepal, he did a lot of work for the whole region. The creation of NPNOG, the creation of NPIX, the creation of many other things. His supporting hand through PCH for training, and then his work through Apricot. It's just remarkable. And that's how we came up with this idea that the regional award should be given to Gaurav. But today we are announcing the national awards. So bear with me. We have a long list of people. So we'll start with the most prominent economy of our region, India. So it took me some time with the help of other colleagues of ours to list down those names. So Internet Enablers has a board, it has a selection process, it has an advisory board as well, which collects people's name. We have an open nomination form. You can submit the form. So we announced it earlier in the year, and then we collected the names and did the due diligence to finalize the names. So first, starting with India. One of the pioneers behind the launch of India's first public internet service through VSNL, the Gateway Internet Access Service in August 1995. As a core member of the engineering and operations team, he helped design, deploy, and operate the infrastructure, then introduced the commercial internet access to India. Over the following decades, he contributed to the evolution of India's internet backbone, Metro Ethernet, MPLS networks, and global IP infrastructure, while continuing to document and celebrate the peoples who collective efforts transform the country's digital landscape. This one person's blog post helped us find the right people. So I would really like to thank him. But before I call his name, I would like to call upon a few names who will help us distribute those awards. So number one, I will call Gaurav as our regional awardee of Internet Enablers. I will call Rupesh as the board member of Internet Enablers. I would call Raj Singh, the CEO of APNIC Foundation. And award. And the last one, I would call David Conrad. And to represent the NPNOG community, may I call Samit? So the introduction I gave you about the person whose blog post made so simple for us to pick the right names, because he put a lot of effort by writing the whole history of the internet on the 76th independence of India. It made our work so simple. So let me call upon Mr. Neeraj Sonkar on the stage to receive the award. All right. Thank you, Neeraj, for an amazing article you wrote. And I think it will become part of the history now. If you want to hear about the story of everyone who will be coming on the stage today, please hold tight. We are conducting the interviews. Their stories will be published on the website and on YouTube as well. So, because it's not going to be justice to give only 5 minutes to explain what they built in decades. So, next one is, let's stay in India for a time being. So, another prominent person from India, he's a technology advisor and one of the India's earliest advocates for public internet access. Before commercial internet services were launched, he co-founded one of the India's pioneering bulletin board system, BBS, helping introduce thousands of users to online communication and internet technologies. During the launch of BSNL's public internet service in 1995, he worked closely with the engineering team to support deployment, customer enablement, TCP/IP adoption, and early internet awareness. He's still very much active in the internet ecosystem and helping the next generation of the internet pioneers. Let me call Mr. Suchit Nanda to the stage. we will do the group photo at the end. We'll do the group photo at the end, okay? So now jumping from India to a neighboring country, let's move to Bangladesh. Moving to Bangladesh now, the person I'm talking about, he's one of the architects of Bangladesh modern internet infrastructure and has been a driving force behind the country's technical internet community for nearly 3 decades now. Beginning his career in 1996, before the internet was widely available in Bangladesh, he helped build early internet services and later played a pivotal role in the growth of BDCom, one of the country's pioneering internet service provider. Not just that, moving to helping establish the BDIX, the Bangladesh Internet Exchange, and then helping establish the BDNOG. I'm sure by now you know who I'm talking about, and that is our very own Suman Ahmed Sabir. All right. Now moving from Bangladesh to another beautiful and lovely economy, a small economy where people are mostly very happy. And I was there last year. That is Bhutan. The person I'm talking about, he's one of the pioneers again of the Bhutan internet and the telecommunication sector, having served in Bhutan Telecom since 1989 in a wide range of technical, operational, and strategic leadership roles. He played a central role in introducing internet services to Bhutan, overseeing the deployment and operations of the country's early internet and GSM mobile networks, while helping shape the Bhutan Telecom's long-term technology and strategy. He also helped in establishing the BTNOG and made possible to visit Bhutan, made possible for Sanok to visit Bhutan multiple times. The person I'm talking about is none other than Jichin Thinley. Now moving to another country, the country of my birthplace. Let's go to Pakistan. The person is among the very few people who brought commercial internet in Pakistan. He was one of the early voices who helped build and document the country's internet ecosystem. During the formative years of commercial internet access, he played a leading technical role at one of the few commercial ISPs called Supernet. That was one of the Pakistan's first private internet service provider, contributing to the development and operations of internet services when connectivity was still in its infancy. Not only that, he created one of the first technical community group on the internet for the people in Pakistan to communicate, to talk, and discuss issues in the telecom and ISP sector. The person is very well known with his initials only. If you tell his initial in Pakistan, people will tell you who you are talking about. As we call him TM, his name is Mr. Tariq Mustafa. All right. Last but not the least, let's come back to Nepal. We started with the regional award for Nepal, and now we are back to the national award of Nepal. He's the founder. If I tell you that, you'll figure out who I'm talking about. So let me skip who is that person from the first statement, right? He's the founder of the Nepal's largest internet service provider, a graduate of Bates College in the United States. He founded this organization in 1995. I'm giving you hints so that you can figure out who that person is. So this organization network expanded to reach nearly every district of the country, and its backbone now carries close to half of all the Nepal's internet traffic. With high-speed internet reaching almost every city and even the most remote parts of the nation, including the far reaches of Karnali, the place I have never visited. What journeys? I just gave you the name. Anyway, this organization's journey from KBPS to TBPS, from dial-up to wireless to Metro Ethernet, and onto its pioneering fiber-to-the-home network is the driving force behind Nepal's achieving the highest broadband penetration in the region. The organization I'm talking about is WorldLink, and the person I'm talking about is none other than Mr. Dilip Agarwal. So from India, Mr. Neeraj Sonkar and Suchit Nanda. From Bangladesh, from Suman Ahmed Samir. From Bhutan, Mr. Jichin Thinle. From Pakistan, Mr. Tariq Mustafa. And from Nepal, Mr. Dilip Agarwal. On behalf of the Internet Enablers Board, we welcome you all on board as the Internet Enablers of our region. Thank you so much for your effort, and thank you very much for that. Hello. So thank you so much for staying late. We are now taking a tea break. But just remember, this is a very short tea break. It's 15 minutes only. Right now it's 11:40. We expect everyone to be back in 15 minutes. Bring your tea, coffee, your samosa, your cookies inside, and enjoy the rest of the session. Thank you so much.
While everyone can go for a quick tea, I'd like to request SANOC core committee members and NPNOG board to stay back for a quick photo. SANOG core committee members. I'm not sure whether everyone is inside. Can somebody help call SANOG core committee members to come in, as well as NPNOG board members? Samit, Suman, and Pankaj SANOG core committee. You can also come. You're a steering committee member. Jichen. Oh yeah. Harish Bhai is there. So only Pankaj is missing. Can somebody call Pankaj?
Okay, good. Everyone, please be seated. And everyone that is outside, please come in. We are going to start this next session. Okay, I'll want to make some housekeeping. Please put your phones into silent mode. Please make sure you don't have any alarms going off. And if you need to take a call, please exit and enter from the back door. Don't use the front door, and somebody's just doing that, because that creates a lot of noise. Yeah, please just use the back door, not the front door anymore, after the session has started. Thank you so much. This is the first session after our opening ceremony. And in this session, I have 3 presentations. We'll start with Devdas Bhagat. He is going to talk about mental models, right? Devdas is one of those speakers and participants who was here for the first SANOG 23 years ago in Kathmandu. And he's been a continuous supporter and speaker on various topics that he's been working on. I know when I first came, he was this very avid anti-spam guy. Then over the years, he turned into a database guy. And now he's turned into a philosopher, and we'll talk about mental models. Devdas.
Thank you, Gaurav. Sorry, so how do you start the slideshow? Cool. There we go. Oops. Yeah. So this is mostly a talk about naming things, not philosophy. Though in computer terms, it might be the same thing. But a mental model is, most people might not be familiar with the term, so let me start by naming that. It's basically an internal representation, something in your mind, of what is an external reality. So you could say a mental model of a thunderstorm, and you can picture it. And if I tell you to imagine an apple, you should be able to see an apple, hopefully. But your level of what you think of as an apple would be very different. So a mental model is useful for us as a framework to help us understand systems and make decisions. A few months ago, I was having a discussion with my colleagues about how we were going to have microservices within the company do stuff. And we spent 3 days arguing about layer 7 versus layer 3 equivalent on application stuff. Just how to do message passing. It was like, should we use this protocol or not? And it was like, it doesn't really matter. You have to do message passing end of day. Whether you use HTTP, whether you use Unix sockets, XML, whatever, it doesn't matter. This is your API definition, go with it. So yeah, just being able to explicitly have that mental model of how to do message passing would have saved us 3 days. You can have the same problem with users. You know, what is a user to your accounting department might be very different from what is a user to your network engineering department. And if those 2 definitions don't align, well, you have a problem. Maybe. A mental model, of course, is a model. It's not accurate. All models are wrong, but some of them are useful. So the goal here is to try and make sure that people can align on what is the usefulness of the model and do not get lost in the details. Utility is the more important thing here. Maps. So my slides are mostly examples of mental models, and there are way more. You can choose to define more concepts as you build more layers of abstraction. We all know that the solution to any problem in computer engineering is add another layer of abstraction. It's there in an RFC, in fact, so you could go look that up. I think 1925, or is it 1125, but somebody can fact check that. It's the 12 networking truths or something. For those of you who don't know this picture, this is the pale blue dot. Useful search term. A 1:1 map of anything is useless. You don't need all the details. A 1:1 map of a country is the size of the country. You don't want to carry that around. But it is a useful model of whatever territory you're covering. You want to build a network, and your network may have, in this country, it might go through mountains. In other countries, you'll have to dig tunnels or whatever. And you know what? As a network, as a layer 3 engineer, I don't care. You're like, I want to have a connection between these 2 points. I will draw a straight line between these 2 points. So that's basically a model. Mental model for OSI. It's like Matryoshka dolls. You just have layers and layers of communication. We don't actually use this in production. TCP/IP is a different model. But when we are talking to other engineers, it is useful to say this is a layer 3 problem, this is layer 4, this is layer 7. Firewalling at layer 3, okay, clear. Firewalling at layer 4, clear. Firewalling at layer 7, yes, we call that an application proxy instead of a firewall, but same thing. But having that mental OSI mental model shared across everyone means you know what everyone agrees to when we say it's a layer 3 issue or a layer 1 issue. Layers are separated by well-defined boundaries, which is part of the model. This is the key part here from the OSI takeaway. Networks, the systems to move information around from point A to point B. What's in the middle? I don't really care. Network engineers do physical. You might care about whether it's a fiber optic cable or whether it's wireless. Again, if you're looking at it from the top-down perspective, I just need to move information from point A to point B. The network is how we do this. It could be a network made of roads, it could be railways, it could be anything else. Trees, in fact, look very similar. So does the human circulatory system. If you want to move stuff around, well, simplest network is a direct connection, but your mental model can just then expand because you say, well, here's a connection, but I have more points. I will connect all of them. And then you say that gets too complicated, so we'll just run it as a star and spoke. And when I say there's a hub and spoke model, everybody knows what I'm referring to without having to draw a diagram. Or a mix, we don't care. Fractals are just patterns that repeat themselves. So another very common use of useful mental model, if you're doing traffic engineering, shortest path, BGP communities take your pick. We just say every path, every element of this network has a weight. Use the shortest weight, distance, time, money. Doesn't matter, traffic engineering. Oh wait, but calculating the shortest path everywhere is complex. Let me make that calculation in one place. Fine, we'll call it segment routing or MPLS and be done with it. And then you can have any other method of doing the same logic and it'll still be like, okay, here's a replacement. A bulkhead, here's an isolation area. So if you're like, okay, we know things are going to fail. This is how we limit damage. Do I have 5 elements in there? It doesn't matter. Disaster recovery, fine. A bulkhead is a boundary. It's a failure limiting boundary. So when you say something is within a bulkhead, you know that it is going to have that's your area of impact for a disaster. Why? Because if you want to maintain capacity, availability, reliability, whatever, all the nice ilities, you need to think in terms of bulkheads. Because if I have a BGP incident when somebody puts up a wrong route and says, well, we are now the default route for the internet and nobody's filtering stuff, you really, really want that bulkhead to be like, oh no, my age is a bulkhead. So we don't want to propagate this out. Or, you just announce YouTube. Or all of AWS, if you like. It doesn't matter. Traffic segmentation, split by type, or we call it label switch path. And then I have, there's a bunch of mental models that I found useful when debugging problems or when designing solutions. So first principles thinking is literally you start drilling down to what is the basic problem that we are trying to solve here. It's not necessarily that a link is, okay, my alarms are going off, but why? And then you start drilling down to, okay, we have a problem because we have a single point of failure somewhere in the path. Of course, you can have multiple single points of failure in the path, which is a very common infrastructure issue. But an axiom is basically an assumption that you have put into your system and said this is going to be true. Your axiom may be that the network is reliable. It isn't, but it can be a valid assumption at the start of your network engineering journey. And then you say, what if that wasn't true? What if something was different? Well, we say, well, people are making unauthorized changes. Are they making unauthorized changes? I don't know. And then you can say, well, what if we can prevent people from making unauthorized changes by using other tooling? Software, this is a solved problem in software engineering. We have continuous integration, continuous deployment. So you can say, well, here's where we have our change gates. And we can say, before I make a change, it is looked at by somebody else, it is reviewed, there is sign off. The 4 eyes principle is a very common example of how you do it. And then you say, what if one of these assumptions is wrong? Maybe your network is not reliable. Maybe you need a second path. Or maybe the network is perfectly reliable, but somebody else is making policy decisions that no longer make your network viable. Pretty common, right? Somebody says, let's just turn the internet off. And then you're like, whoop, that's a new one on me. Come on. Oh, there you go. And then you just say, I want a new set of axioms, new set of assumptions, and you build a new mental model from there and say, this is my new system. Old systems can be very simple, and new systems can be complex, or if you do it right, the newer mental model of your system will be simpler. But your implementation can have lots and lots of complicated and complex details. And you'll just be like, sure, it doesn't, but those details don't matter in the big picture. You're looking at somewhere between a microscopic view and a 10,000 foot view. Occam's razor, the simplest explanation, is the best starting point. Why is my network down? Well, possibly there was a fiber cut, possibly somebody made a routing change, I don't know, but we just look at when did the incident start and what changed at that time. If you have decent monitoring or half decent monitoring, you will be able to say, there was a change, and then when that change happened, my networks went down. Cool. I know that can be a valid hypothesis for going down the path. You don't need to go, well, you know what, my competitors decided to cut the cable, when you're like, no, somebody made a routing change and made a typo in it. What's more likely? Of course, you have to keep this little adage in mind. Explanation exists, there's always a simple explanation, and that's probably wrong. Kinefin, this is a Welsh word, so it's pronounced as KY, and it divides problems into 5 contexts. Clear, where you use best practices, best current practices. It's all simple, standardized solutions. Complicated, more moving parts. Complex, lots of moving parts and lots of possible inputs. Chaotic, nobody knows what is going on. Incident happening and manager rushes into the room screaming, what is going on? Tell me now. And you're like, I'm trying to troubleshoot this issue, shut up. But the manager doesn't shut up, and it goes from, this is a complex issue to, well, now I no longer know what's going on. And then you have confusion, which is, well, slightly worse. Systems thinking is a mental model where you say everything is a system and any change you make in that system will reflect everywhere else. So the impact may be limited, it may not be limited. And it's a group of interactive parts which is coherently, logically organized. And more importantly, systems have emergent properties. The human brain is extremely complex, but we still don't know how intelligence works. If we could have actual intelligence, it would be nice. Artificial intelligence is not a good substitute. But yes, emergent properties mean that any change can have impact elsewhere. This is a major thing when we deal with stuff like policies or, what are the new rules for making a change? You say, I want to make, we are having too many outages, we should limit changes. And then it turns out a few weeks later that your problem is your change rate is too slow and your competitors are out executing you now. And everything is the system, so you can always just go down through this. And of course, when everything is a system, you need to know what is happening in that system. And a useful model for that is events and queues. Anything that happens is an event. And once you have a series of events happening, it builds into a queue. You have a processor for a queue. And if a queue gets too long, you start to have problems because it takes too long to process information. You get delays. And in network context, you're looking at the equivalent of a packet drop. People forget things. You build up a giant task list. Your Jira queue builds up into, it should be like, here's a 5-item list. And you go, well, how many tickets do you have? Well, 5,000. We can't get through these in a day. It's fine, no big deal. And then now you have to deal with queue management. Queue management is, of course, the queues may be visible or invisible. In a lot of business processes, queues are invisible, which means you can't see them and you can't price them around. And then other people are like, sure, what, it's only a 1-minute task. What's the big deal? Well, I have 500 1-minute tasks to do and not enough minutes in a day. And if you go talk to your accounting department, they will tell you that this whole inventory thing is not great. You don't want to buy more than you want. You don't want to output more than you need, because carrying inventory has a cost. If you say, I want one router, and you say, I will put in an order for 10 routers because I might need spares, your manager is going to go, what? Have you ever thought of your actual monetary costs on this thing? The theory of constraints is another useful model. It basically says that for any system, you have one constraint, one limiting factor. So if your bottleneck is the fact that your latency from point A to point B is 500 milliseconds, whatever you do is not going to go faster than that if that's the limitation because of the speed of light. I mean, if your limitation is speed of light in vacuum, good luck trying to go faster. I understand the Australian Prime Minister believes that Australian laws supersede the laws of mathematics, but the laws of maths and physics tend not to be overridden. If you're saying, I have a 10 gig local link, but the pipe to the internet is 1 Mbps, you're not going to go faster than 1 Mbps. Your optimization really needs to be, how do I upgrade the pipe to the internet? And if you optimize anywhere else, it's basically a waste. You just go, my desktop is 100 Mbps connection and I made it 1 gig and my internet's not faster. Well, yes, because you didn't find where the actual bottleneck was. Your bottleneck may not just be in the network, it may be in your staffing, it may be anywhere. You could have 15 people being on call, and that would be a waste. You could have one person be on call, and then that would be too few. One network engineer running an operation 24/7 is definitely too few. That's the thing that you want to optimize. You will want 3, 4, 5 people so that people can take vacations or be sick. And yes, from systems thinking, you get another mental model, which is leverage. Pareto principle, again, you basically put in 20% of the effort to get 80% of the results, and that's usually good enough. I'm more than happy if I can pay like 20 rupees and get 80 rupees worth of value instead of paying 100 rupees and getting 100 rupees worth of value. Similar-ish. Feedback loops. This is a thing that most people miss out on, but when you make a change to a system, there is always a reflection back, and now you have a new system and a new state, and that output change influences further input. Then, if you have done any sort of electronic damping systems, you'll know that if you have a negative feedback loop, things get stable over time. But if you have a positive feedback loop, well, then small change will cause things to go completely unstable. You're like, yep, here's a tiny bottleneck. And then, well, that bottleneck grows and grows. You have 10 cars on the street, good enough. And then you have 400 cars on the street and it goes, well, now we have a traffic jam. And there's a phenomenon in traffic called a standing jam, where there was a traffic jam and now traffic isn't moving even though there is no obvious cause for the jam. The traffic is just standing still. That's the sort of thing that you have with a positive feedback loop. Positive feedback loops can be useful if they're actually in a place where you want them, like your revenue. I would like it to grow. As a business, you would like it to grow. You don't necessarily want it to be stable. That's a limiting factor. But if your network is going into a state where you're going, well, we have all this, it's just flapping and flapping and flapping. You're like, yeah, that's a problem. And inventory in queues causes problems with feedback because, of course, inventory means if you've got 5 minutes of inventory, you're stuck waiting for feedback for 5 minutes, stuff has gone wrong, and now you have to wait 5 minutes to know if your fix worked. It might be 5 minutes, it might be 15 minutes. If you're really unlucky, it takes hours to know if your fix worked. And then you're like, well, I don't know if the outage is resolved. Basically, mental models are the starting point for your decision making. They're not anything other than that. It's simplifying a very complex problem into saying, when I say X, I mean this whole big thing behind it. I don't have to describe every tree and every mountain in the Himalayas, but if I tell you Himalayas, you're going to be like, okay, big mountain chain, we know where it is, good enough. And that's basically the point where you want to get to with a mental model. Having more mental models just gives you more options to select from. And you can go, I have a different set of mental models than my colleague. I have more experience in different fields. And that means that I can solve problems with a different approach. I have literally solved problems that are really hard to do with simple programming loops. And then you go and say, but if you use recursion here, it will make you model your data as a tree and it makes life simple. And that's a known solution, but you just have to model the data right, which means that's just a problem with this. So we have 3 minutes for Q&A, or we can do the Q&A later. But if anybody has questions. No one? Okay.
Thank you, Fab. I think this is a fascinating presentation. One thing I generally struggle with mental models is how you've applied it in real life. Do you want to share an example where you had to kind of apply this to a problem space and came out of it, either positively or negatively, it doesn't matter. Thank you.
So let's see, this is a hard problem because I keep doing this all the time. And my current example from my current company, like I said, was how do you do the message passing thing? Because it boils down to, my current company grew by acquisitions. Everybody has a different software stack. Everybody has different mechanisms. And so you need to unify all the tech stacks. And at some point we went, well, we have microservices. And it became, well, we have too many microservices, which is another problem you can have. So we are trying to simplify things down to isolate stuff by problem domain. And then each thing has to communicate explicitly by message passing. You need message passing so people don't randomly change APIs, and you don't need to go like, oh no, there's an HTTP API here or a socket, Unix socket, whatever. The message is the important part, not the rest of it. This simplifies the problem for a few hundred developers when they say, you know what, here's the mechanism. This also feeds into our business intelligence systems. Instead of all this common way people do BI is you will copy data from every database that you have and then restructure it. Instead of restructuring the data like that, you can just say, we are going to have a single event that is generated from your messages that you then pass around. And then this day becomes your feed into the business intelligence system, and it is also my feed into my monitoring system. So when I know that an alert is going off, I know exactly what paths were being taken by those things. I know what users are impacted. I know which systems are impacted. I know what deployments have been dealt with at that time. And I can go from something is broken to this is the tiny set of issues I have. This is where I need to look at. And then suddenly your time for resolving an outage goes from a few hours to discover what is going wrong to, well, here are the 5 things we need to investigate. Here are the 5 teams we need to call in, and you can solve problems much faster.
Thanks. Any question for for Devdas? 20 seconds. Can you go to the mic? Please go to the mic. Yeah, Rubens, thanks for it. Mic. Keep the mic there. There's the mic.
So I'm interested in learning what sort of mental model you use when dealing with, let's say, problem at a scale. Let's say you've got millions of customers, right? Or millions of data points, or network, for example. Any particular mental model that really works for you, or you just try whatever comes first?
I mean, you start by modeling a system, and then you see how you're going to deal with the particular problem that you have. You want to isolate those down. So I generally approach everything as a debugging issue.
Okay.
This is a thing, this something is not working right, or something is missing. What do I need to do to make it work, or get things working in? And then you just apply as many mental models as you can to say, if I look at the problem like this, does it work better? Or if I look at it from this other perspective, does it look better? So the more your mental model is essentially a perspective.
Yeah.
Do I care about DNS? Not really. But if it doesn't work, we know everything is going to break.
Yeah.
So,
cool. Thank you. You guys can take it offline.
Yes.
Time's up. We will go on to the next presentation. Please introduce yourself next time you ask a question, because we also are live streaming this. And so we want to know who is asking the questions. Thank you. The next presenter is going to talk about how to keep the local internet running during internet shutdowns. This has been a kind of popular topic in our region recently. So, you know, I'm getting Suman Bhai here, and he's going to talk about this in context of the July Revolution 24 in Bangladesh, which also gave birth to Bangladesh 2.0. Suman Bhai.
Thanks, Gaurav. Good afternoon, everyone. So let's now move from psychology to politics. So the presentation I made actually last year in NPNOG 19, after the July Revolution 24. We have a huge outage, and we lived without internet for almost 3 weeks. And that triggered me to prepare this presentation, actually. Even if you fall into that kind of situation, still, we can do much better what we have done that time. So I want to share my experience and a few things we can do better. Definitely, we don't want to see the internet shut down again. That is, we don't want that to happen. If you can build that consensus, that's the best thing to do. But so far, you can see we can't avoid it. People from Delhi who are here maybe experienced some of it in the last week. So it's all began with a very small issue, actually, that the students start protesting for, So there is a quota system in our job market, in the government jobs, that people with minority community, people with underdeveloped community, and also quota for the family members of the freedom fighters back in 71. And if you accumulate all the quota, it comes around 65%. So for meritocracy, it's only 45% left. So there is a huge hesitation among the students that it's all about quota, not merit. And it's 71 legacy were still continuing in 2024. So students started protesting, and the usual, the autocratic government tried to move in different directions, and it started getting momentum, and we started seeing this kind of situations in the streets. And suddenly in 16th of July, we found that mobile internet gone off, and 18th evening, everything was shut down. And that's a very strange feeling. I don't know how many of you that kind of feeling that suddenly you have no internet connection. But I feel that half of my life I spent without internet. But now, when this happened, and I was started thinking that I'm kind of disconnected. We're living in a very much connected world. I can see Tariq Bhai sitting here, and I probably am seeing him after 25 years, maybe 20 years, and but I know that we are connected. And many of us in this room, we are not seeing every day, but we know that in a moment, if you want, we can reach to anyone. If the time zone doesn't mess, maybe next morning he will respond. But we know we are connected. But that is the feelings that I'm completely isolated from everyone except the family in my house. So, and it's looked like that suddenly we gone off from the internet. And probably the government was trying to hide this kind of gloomy pictures that was happening in the streets of Dhaka city. And our minister told that we didn't shut down the internet, but it stopped. So I don't know how. And if I show the time frame, what happened, that on 16 July onward, mobile internet shut down. 18th evening, around 8:30 p.m., all internet was gone. And on 25th July, there is a partial restoration of broadband internet only for the emergency services. 28th, we got internet back, but except the social media. From 31st July, the mobile broadband returns, but the situation in the streets didn't improve. On 3rd July, again, mobile internet went down. On 5th August, for a couple of hours, we have completely shut down again. And after that, the government actually gave up. Everything changed, and we got our full internet service back. So, and even during the partial shutdown time, we noticed that the VPN traffic increased a lot. That is usually around 20 to 30 Gbps, but during that time, we found that around 400 Gbps traffic is coming out of the VPN because people are accessing social media via VPN. So, and on the 5th August, that again fully shut down, and we called it the very famous 36 July because the continued July revolution till 5th August. And so that is a very strange experience I was sharing, that it is not only the personal feeling, but it impacts a lot actually among the people during the shutdown time. That now a lot of people depends on e-commerce. The technical people, a lot of companies, individuals, they do outsourcing work. They have managed contact with overseas companies. They're providing 24-hour services. All these people are kind of out of business. And I found a lot of people, those who have Indian visa, they cross the border. Some people actually travel to Kathmandu because we have a visa-free entry in this city, and they start working sitting in the hotel here. And very common that mobile money, we know that we all transfer money through mobile. It's a huge, huge transaction. It is stopped. The POS machines in the shops not working. E-commerce all gone. E-commerce on top of social media and individual website is very popular now. It's a lot of business going on here. And all these are stopped. The worst thing that the electricity, gas, water, these are all not prepaid. and they cannot recharge that. So some people, we see a lot of queue during curfew in front of the electricity office because they're out of electricity. Even somebody wants to call, those have prepaid mobile, they cannot recharge their mobile phone. So complete life actually shattered. Interestingly, the way internet was shut down, it was just turn off the upstream. The local internet ecosystem was actually available, and we can ping and reach to every destination inside the country, but no content is accessible. Even the local apps, those people use in the Wi-Fi, you can use all the time, but those are not accessible because some of the apps are hosted in the cloud, they're backend. Some are using some scripts, JavaScripts or API,